We proposed a bio-inspired robotic system to learn multisensory cue integration and image stabilization. The motivation of our work is to enable robots to learn intelligent behaviors through interaction with the environment in the same way as an infant. We use the active efficient coding framework to achieve such a self-developing cognitive structure. The ECE framework extends Barlow's efficient coding hypothesis to include behavior. It posits that not only the neurons in the brain develop to encode the sensory input efficiently, but the behavior of the agent develops to shape the sensory input so that it can be efficiently encoded. The main contribution of our work is that our model learns autonomously and accounts for the development of both multimodal sensory processing and motor action. The first video illustrates the joint development of motion-selective receptive fields and stabilization behavior during training. The left side shows the evolution of the spatial temporal basis functions in the sparse coding dictionary over time. The middle illustrates the emergence of stabilization behavior in the robot view. The red square indicates the target location being viewed by the fovea. The right side illustrates third-person view of the robot. At the beginning, basis functions begin with random initial conditions, and the stabilization behavior is random. Some of the basis functions evolve quite quickly to exhibit spatial temporal Gabor-like profiles, and the system learns stabilization policy, albeit with some errors. As more basis functions develop Gabor-like profiles, the stabilization behavior improves. The second video shows the learned behavior tested at the end of learning with different sensory cues. The top row shows the stabilization behavior. The bottom row shows the eye and head trajectories. 3 columns represent different sensory inputs. From the trajectories, we can see that the eye movements almost compensate for the head rotation with both visual and inertial inputs. With only inertial inputs, the performance is worse. The performance can also be compared by observing the retina slips in the first row. In conclusion, we have presented a system for learning multisensory cue integration for gaze stabilization. The system is formulated in the active efficient coding framework and autonomously learns to exploit visual and inertial cues to effectively stabilize the gaze of a mobile robot.